So welcome to the session on Max on vector calculus. So here we are going to deal of calculus of vectors. So the first thing we need to understand is what do you mean by vectors. Vectors, as we know, are quantities having both magnitude and direction. Correct? This what is this. So first we need to understand two basic terminologies, that is what do you mean by dot product and what do you mean by cross product. These are two important terminologies which we are going to use very much. So a dot product is also called as a scalar product. Okay, a dot product of two vectors is what you are going to say. Say for example, A is one vector, this dot B vector, this is what is called a dot product. Now why we were interested in doing this? The formula, if you go by the formula, it is mod A mod B cos theta. See, A is a vector, B is a vector, whereas the result is a scalar. Please remember it. That means it's a number. A and B are not numbers, A and B are vectors, whereas the result is a scalar. Okay, now why I am interested in doing this is, let me say that this is my A vector, this is my B vector. I want to know the projection of B vector on A vector, that is the projection. Projection means what? In common language it is shadow casted by B on A, or in technical language it means component of B vector along A vector is what we are trying to find. So that is this is the angle theta. Now when I project it, what will I get? I will be getting this. I will be getting this. This is the image of B on A vector. Correct? Now how dot product is going to give me? What is this? This distance by basic triangle, that is basic trigonometry, is nothing but by using the basic geometries and the concepts of trigonometry. This, if I call this as OPQ, OP is nothing but OQ cos theta. Correct? That is nothing but that is mod B cos theta. Mod B cos theta is nothing but mod A mod B cos theta divided by mod A. That is nothing but A vector dot B vector divided by modulus of A vector. So this modulus of A vector, whatever I am dividing, is just a number. This is the actual component. Correct? So A vector dot B vector can give me projection. That is, by knowing the A vector dot B vector, I can find the projection of B on the vector A. Similarly, if there is some other vector called C, if I do C vector dot B vector by mod C, I will get projection of that on projection of B vector on C vector. So dot product is ultimately going to give me projection, that is nothing but the component of B along A. This is very important. Okay. Now let us come to the story of cross product. So what do you mean by cross product? Cross product is A vector cross B vector. The result is going to be another vector. So the source is also vector, the result is also a vector. This is very important. That means C is going to have a direction. See, here the result is a scalar. So when you say scalar, the scalar will not have any direction, whereas C vector is the result of A and B cross product. That means C will have a direction. Okay. Now the relation of A cross B is given by A B sin theta n hat, where n hat is the unit normal vector to the plane containing A vector and B vector. Or also I can write A vector cross B vector as I, J, K. If A1, A2, A3 are the components of A vector, B1, B2, B3 are the components of B vector, it can be written like this. That is, my A vector is nothing but A1i plus A2j plus A3k. Similarly, my B vector is nothing but B1i plus B2j plus B3k vector. Now understand that A vector cross B vector is perpendicular to both A vector and B vector. Please remember this. This is very, very important, because clearly it is told that n hat is the unit normal vector perpendicular to the plane, unit normal vector to the plane containing A vector and B vector. That is, normal is always perpendicular, correct? So there is a plane which contains A and B. So the n hat is in the direction which is normal to the plane. That means it is perpendicular to all the vectors contained in the plane. That means it is perpendicular to A vector and B vector also. Clear? Now what is the meaning of A cross B? This is very important. The thing, what is going to be A cross B is nothing but rotation. It is going to give you the rotation potential or the torque. In other words, in pure mechanical terms, I have to say it is going to give you the torque. Now, one more important thing you have to remember, since A cross B is a vector, the direction of A cross B, magnitude of A cross B will be same as magnitude of B cross A. But direction of A cross B is not equal to direction of B cross A. Both are in opposite direction. Therefore, on general basis, I can say A cross B is not equal to B cross A. So, these are the basics which are very important for proceeding ahead in vector calculus. Clear? Fine. Next important thing we are going to see is the vector differential operator. It is called the del. It is a vector I dou by dou x plus j vector times dou by dou y plus k vector times dou by dou z. See, it is not a vector as what we say like a vector or a B vector, which is a1i plus b1j, a1i plus a2j plus a3k. It's not a vector. Del is not a vector like this. Say for example, I have a vector called a1i plus a2j plus a3k. These are numbers. A1, A2, A3 are numbers which are weighting the I vector, J vector, K vector along the respective directions. So we get a vector A. This del is not this type. Del is a operator. It is not a general vector where you can quantify it. Del is a operator. So as such, del has no meaning. Only when you operate it on some scalar or vector, then it gives you a meaning. Okay. As such, del has no meaning. As such, del has no meaning because it's an operator. See, if I say what is the meaning of plus? Plus will have meaning only when you put one number before that. See, if I write simply plus, it has no meaning. Only when you write 3 plus 5, then it has meaning. Because this is a number, it is being operated by this plus to give you this result. As such, plus has no meaning. Correct? As long as you don't know what is sitting here and what is sitting here. Correct? So, as such, del has no meaning. It has to be supplied with some operands. Then only it will have meaning. Clear? Okay. Now, the first operation we are going to see is called the gradient. Gradient is always calculated for scalar fields. So, let phi be a scalar field. Scalar field in the sense scalar function. Okay, as such in mathematical term it is a scalar function. And then I define gradient of phi. I write it as grade phi. Grade phi as del phi. The result will be a vector. Please remember that phi is scalar, whereas del phi is a vector. See, it is a del is a vector, phi is a scalar. Now you are scaling the vector del by phi. That's what it means. That is, you are operating del with phi. I'm sorry, you are operating phi with del, because del is the operator, right? Sorry, I told it in the reverse way. Okay, fine. Now please remember, del dot phi or del cross phi are meaningless. Please remember these things, because whenever you take a dot product, you are allowed to take a vector dot b vector only. You cannot take a vector dot b. This is wrong. Similarly, for cross product also you have only a cross b. You cannot do a cross b, which is a scalar. This is meaningless. Similarly, del is a vector. So del dot phi is a scalar. Del dot phi and del cross phi are meaningless. Only you can do del phi. Clear? Del phi means what? That is, del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z of phi. It's nothing but I vector times dou phi by dou x plus j vector times dou phi by dou y plus k vector times dou phi by dou z. This is what is called grade phi or gradient of phi. Now what is the meaning of that? Now I have understood del, but what is the meaning? Ultimately, why I am doing it? This is very important. The meaning is, del phi is giving the variation of scalar function phi along its normal. That is, along the normal to the phi at that point. Now what is the use of this? The use is, we can find variation of phi along any direction at that point by projecting del phi on that direction. So it might, like I have told many things in English here, we will see it in a pictorial form. It will be very helpful. So I will just read out what I have written. Del phi is giving the variation of the scalar function phi along its normal at that point. We can find variation of phi along any direction at that point by projecting del phi on that direction. We will see the meaning of this in the next. Okay, let me take a scalar function like this. Let me take, say this is some surface. Okay, so this is a point. So the normal to this point will be in the, say this is the normal. At say this point, let me call this as P. So this vector, let me call this as K vector, the normal vector. Okay, let me not take K. Let me take it as N vector, because K means there is also another K, you should not get confused. So this is the normal vector. Now, okay, this is phi, this function is phi. Now del phi is giving variation of phi, or rather del phi, I will put it like this, del phi at point P is giving variation of phi along n vector. What is n vector? Normal to phi at P. Okay, see, I am evaluating del phi at point P. So at point P, n vector is the normal vector. And del phi is going to give me the variation of phi along the n vector. Now let me say there is some m vector in this direction. What is the way? Now if you know the variation along normal, you want to know what is the variation of this phi along the direction of m, you simply project this on m. So this will be the variation of phi along m. So variation along any direction can be calculated. Can be calculated by projection of del phi, correct? Yes or no? At that point, now if I don't put any point, I will get del phi as a function. Then at every point, by substituting the corresponding value of that point, the coordinate value of that point, I will know the variation at each and every point, and at each and every point I know the variation along normal. I can find the variation along any direction given the point. Clear? Is this clear? Okay. I repeat, if I don't substitute, see here I am evaluating at point P. That is, you will be first finding del phi and you will be substituting for the point P. So you will get del phi as a vector, not as a function. And then you will project that vector on this vector to find what is the variation along m. Now if I don't substitute the value of point P, you will get del phi as a function. Now instead of P, you want to find it at Q, you substitute the xyz value of Q. Now it will give the variation along the normal to Q. Now you can find the variation, say for example, let me call this as nq vector. You can find the variation of along mq vector by projecting the normal here. Clear? This is what we are going to do. Now let us solve problems. When we solve problems, it will be more clear. So let us solve problems now. The first thing we are going to solve is, let phi and psi be two scalar functions. What is the value of del phi psi? So what we are asked is, phi comma psi are scalar functions. Now what we are asked is del of phi psi, means what? Gradient of phi psi. Now what is this dot? This dot is not dot product. Please remember that, because dot product can be taken between only two vectors. But phi and psi are scalars. Remember that, okay? This is very important. So this dot is just a multiplication. Like how I write 5 into 2 as 5.2, like that only it is. Okay, now let me write the meaning of it. If I expand this, what will I get? I vector times dou by dou x plus j vector times dou by dou y plus k vector times dou by dou z of phi psi. Now I can operate it now. If I operate it, what will I get? I vector times dou phi psi by dou x plus j vector times dou phi psi by dou y plus k vector times dou phi psi by dou z. Now we have to solve this. Now if I recollect from the basics of differentiation, what is differentiation of uv? D by dx of uv is what? It's nothing but u dv plus v du, product rule, right? Product rule. So if I use the same thing here, what will I get? Phi and psi are two functions. So this can be written as what? Phi times I vector is separately outside. Phi times dou psi by dou x plus psi times dou phi by dou x plus j vector phi times dou psi by dou y plus psi times dou phi by dou y plus k vector times phi, dou psi by dou x plus psi times dou phi by dou z. Now if I group the I, j, k terms, what will I get? I can simplify this and write it as phi into, see there is one phi term here, there is one phi term here, there is one phi term here. These are scalars, right? I can take it out. So if I write it out, what will I get? Phi times I dou psi by dou x plus j times j vector dou psi by dou y plus k vector dou psi by dou z plus phi. Similarly, phi I have here, here and here. I can group them. Psi times dou phi I vector dou phi by dou x plus j vector dou phi by dou y plus k vector dou phi by dou z. So this is nothing but what? Phi times, this is nothing but what? Grade psi, right? So del psi plus psi times del phi. This is what it is. So this is a very important result. Please remember. Gradient of phi psi is nothing but phi gradient of psi plus psi gradient of phi, where phi and psi are scalar functions. Clear? Now, as we saw in the previous page, so the meaning of del phi, what is the del phi can be used for? Del phi can be used to find variation of phi along any direction by projecting del phi on that vector, correct, on that vector. What is this vector? This is that vector which is describing this direction, correct. This is the vector which is describing this direction. Okay, that's what it is. Now this variation along any direction is called directional derivative. It is called mathematically as directional derivative. Okay, so ultimately if you are asked to find directional derivative, what you have to find del phi and find projection of del phi on the given vector. That's what we have to do. Okay, let us solve a quick example related to this. It will be more interesting. Find the directional derivative of phi, which is a scalar function given by x square yz plus 4xz square plus xyz at point 1, 2, 3 along 2I plus j minus k. This is what is told. So first thing is we have to find, so the solution is this way. Find del phi at given point and project it on the given vector. Okay, this is what we are going to do. So phi is given. So what is del phi? Del phi is nothing but I dou by dou x plus j vector dou by dou y plus k vector dou by dou z operator on phi. So it's nothing but what is phi here? Phi is given to be what? I vector dou by dou x times what is 5 here? X square yz plus 4xz square plus xyz plus j vector times dou by dou y of x square yz plus 4xz square plus xyz plus k vector dou by dou z x square yz plus 4xz square plus xyz. So on differentiation we are going to do partial differentiation. So what we will get? I vector times dou by dou x of this. So what will be dou by dou x? X square, y and z are constant when I am going to do partial differentiation with respect to x. So this part will give me 2xyz plus 4z square plus yz. Correct? Plus j vector times, here I am going to do dou by dou y. So x and z are constants for me, so this will give me x square z plus 4xz square will give me 0 because there is no y term, plus xz plus k vector times, what will I get? X and y are constant because I am going to do partial differentiation with respect to z, so this will be x square y plus xz square means I will get it as 8xz plus xy. So this is what is del phi. This is generally a function. Now this is a function which is giving you the variation of the of the given scalar function along the normal. Along normal means what? There is no point. This is the variation to the normal to the entire surface. Now when I put the point, automatically it will give me the variation of the function phi along the normal at that point. That is very important. Clear? So del phi at 1, 2, 3 is what? That is what we have to calculate. Now you substitute for x as 1, y as 2, z as 3. So del phi will be what? If you substitute, what you will get? 2 into 1 into 2 into 3, like that. When we substitute everywhere, 1 as x, 2 as y, 3 as z, we will be getting del phi as 54 I vector plus 6j vector plus 28k vector. This is what we will be getting, 28k vector. Now we have to find the directional derivative. Directional derivative, in short I will write it as dd. Directional derivative, in short I will write it as dd. So dd is nothing but what? Del phi dot given vector divided by modulus of given vector. That is what it is. So along which direction we are asked? 2i plus j minus k. This is the direction we are asked. So we are going to project on that. That is nothing but 54i plus 6j plus 28k dot 2i plus j minus k by modulus. How will you calculate mod of a vector? It's nothing but x a square plus b square plus, that is the component along the I square, root of the component along I square plus component along j square plus component along k square. So that is nothing but 2 square plus 1 square plus minus 1 the whole square. This is nothing but, when you take the dot product, how will you take dot product? We will take the corresponding terms. So this is nothing but 54 into 2 plus 6 into 1 minus 6 into 1 minus 28 into 1 divided by root of 4 root 6 you will get, right? Root 6. So the final answer will be what? 54 108 minus 28 plus 6 is 86. 86 divided by root 6. This is the answer. This is the answer. 86 by root 6 is the variation of del phi, where phi is given by like this at point 1 comma 2 comma 3 along this. So the answer is 86 by root 6. This is the answer. Okay. Now this is another interesting question.